All right, buckle up for a deep dive, you guys, into some seriously mind-bending territory.
Oh, this is going to be good.
We are talking about scientific experiments and theories, get this, about whether the Earth actually moves or not.
You know, it's fascinating, isn't it?
I know, right?
These alternative models of the universe,
Yeah.
often dismissed as fringe theories,
Right.
they just keep popping up. They
Yeah.
keep inspiring debate, even among, serious scientists.
And some of the challenges come from big names in science, which we'll get to.
Absolutely, yeah.
But first, let me tell you a little bit about our main source today.
Okay.
It is an audio clip, very provocatively titled, "Ed of the Flat Earth Finally Found Eero Air. This Will Blow Your Mind." .mp3.
Catchy.
Now, before anyone jumps to conclusions, our goal here is not to endorse any particular viewpoint,
Of course.
but instead we're going to unpack the arguments and the evidence, present them,
Right.
and compare them to the broader context of established scientific knowledge.
Right. So it's like we're piecing together this puzzle. We're looking at each piece.
Right.
And we're seeing how it fits with the other pieces, considering different perspectives.
Yeah,
And how these ideas have evolved over time.
that's a great analogy.
Thanks.
So to set the stage,
Yeah.
let's go on a little journey, a little time travel, back to the late 19th century.
All right, hop in the time machine.
Back then, most of the scientific world embraced the Copernican system.
Right.
You know, the Earth revolves around the sun.
Yeah.
But there were some unresolved mysteries even within this framework.
Always.
One of the biggest puzzles was this concept of ether.
Ah, the ether.
Scientists back then, they believed that light needed a medium to travel through, like sound waves need air.
Right, makes sense.
And so they called this hypothetical medium ether, and they thought it filled all of space. So they were thinking there was this invisible stuff that light waves travel through.
Yeah, it was a wild concept.
Yeah. So this idea of the ether led to one of the most famous experiments in the history of physics,
Here we go.
the Michelson-Morley experiment
Ooh, yes.
in 1887.
Michelson and Morley, those guys were clever.
I know, right?
They designed this experiment to try and detect the Earth's movement through this ether.
Oh, okay.
And the idea was, if the Earth is moving, it should create a kind of ether wind
Right.
that would affect the speed of light depending on the direction.
Okay.
You know, similar to how, like, a swimmer's speed changes depending on if they're swimming with the current or against the current.
Okay, that makes sense. So I'm sensing that things didn't go quite as planned.
You got it.
What happened?
Well, what they found was a complete shock. The experiment failed to detect any movement of the Earth through the ether.
Really?
This null result, as they called it, became a huge puzzle for the scientific community.
Yeah.
And it led some to really doubt, the existence of the ether at all.
That's a pretty big deal, right?
A big wrench in the works, you could say.
It is, yeah.
So then, of course, the big question became, how do we explain this?
Right. So how did scientists try to explain this unexpected result?
Well, there were a few attempts to reconcile this null result with this idea of a moving Earth.
Okay.
One of them was the Lorentz-Fitzgerald contraction theory,
Okay.
which proposed that objects moving through the ether, they actually shrink in the direction of their motion. So imagine a spaceship, right?
Yeah.
Traveling super, super fast.
Yeah.
According to this theory, it would actually get shorter, the spaceship would, in the direction it's moving.
So they basically said that to make the experiment fit the model of a moving Earth, things actually physically change size as they move.
Well, yeah, essentially.
It seems like a pretty, far out idea.
You're not alone in thinking that. It was very controversial.
Yeah.
A lot of scientists saw this as a pretty desperate attempt to salvage the existing paradigm.
Right.
And there wasn't any independent evidence for this kind of contraction. So it felt like, yeah, like you said, trying to fit a square peg in a round hole.
Yeah, it does. It really does. So it sounds like at this point, the scientific community is grappling with some pretty mind-bending ideas. Did any other explanations emerge?
Well, that's when, dun dun dun, Albert Einstein enters the picture
Oh, here we go.
with his groundbreaking theory of relativity,
Okay.
which was a radical departure from the traditional way of thinking. He completely did away with the concept of the ether
Really?
and proposed that the speed of light is constant for all observers, regardless of their motion.
Okay, so no more ether wind to worry about.
Exactly.
But hold on, if light doesn't need a medium to travel through, then how does that even work?
That's the beauty of it and the challenge of it, right?
Yeah.
Einstein's theory, it redefines space and time,
Whoa.
suggesting they're not absolute, they're relative to the observer.
Wow.
So it's a tough concept to grasp.
Yeah.
But it did provide an elegant solution to this whole Michelson-Morley dilemma.
Okay, so we've got these two competing explanations for this mysterious null result.
Right.
One that's kind of tweaking the existing model
Mm-hmm.
with this strange contraction theory, and then another that throws out the old rule book entirely.
Yeah.
This is getting intense. I have a feeling this isn't the end of the story, though, right?
You are so right.
Totally.
Just when things were starting to settle down, another experiment came along.
Uh-oh.
Threw another wrench in the works, the Sagnac experiment in 1913.
Oh, no, this is where it gets interesting. Tell me more about this Sagnac experiment.
Okay, so this experiment involved sending beams of light in opposite directions around a rotating platform.
Oh, okay.
What they found was that the light beams took slightly different times to complete the circuit,
Oh.
which shouldn't happen if the speed of light is truly constant, as Einstein said.
Wait a minute. So this experiment is suggesting that the speed of light can be affected by motion? But doesn't that directly contradict Einstein's theory?
Yeah, that's the thing. And what makes it even more interesting is that the results of this Sagnac experiment are actually used in technologies we have today,
Really?
specifically ring laser gyroscopes,
Okay.
which are super important in navigation systems, like in aircraft and spacecraft.
Hold on. So we've got planes flying around using technology that's based on a concept that Einstein supposedly disproved.
Seems like it.
Yeah.
It's almost like science took this paradoxical side road for a while.
I know.
So, if the Sagnac effect is real and valid,
Yeah.
it suggests the existence of a preferred reference frame, which goes against a key principle of Einstein's relativity.
Oh, wow.
And that just opens up some pretty big questions about how much we really understand about physics.
Yeah, I'm starting to see why this is so mind-boggling. And I'm guessing there's even more to uncover as we go on with this deep dive.
Absolutely. The audio clip goes on to mention some other experiments like Airy's failure and the Michelson-Gale experiment,
Okay.
which allegedly support a stationary Earth model. So we'll be diving into those as well.
This is fascinating. It seems like every answer leads to even more questions. I can't wait to see where this deep dive takes us next.
Me too. Let's do it.
Okay, so we've got these experiments, right?
Yeah.
That seem to challenge the whole idea of a moving Earth.
Right.
But mainstream science must have, addressed these challenges. I mean, right?
Well, that's where things get even more interesting. The audio clip highlights these criticisms of relativity, and not just from French groups,
Wow.
but from some pretty big names in science.
Wait, are you telling me there are respected scientists who question Einstein? Now I'm really interested.
Oh yeah, one of the most notable was Herbert Dingle,
Okay.
a physicist who was actually at first a huge advocate for relativity.
Okay.
He even wrote textbooks on it.
Wow.
But later in his career, he found what he believed to be a paradox within the theory.
So you mean like a logical inconsistency within the theory itself?
Yeah, exactly.
Mm.
And Dingle, he spent years trying to find a solution within the scientific community.
Right.
But he ran into a lot of resistance.
Really?
He even felt like he was being censored when he tried to publish his findings.
Wow.
So this struggle led him to write a whole book called Science at the Crossroads, where he kind of laid out his whole critique of relativity.
That's fascinating. She was really ostracized for daring to challenge such an established theory. I mean, what was the core of his argument?
Well, he argued that mathematical formulas, while they're powerful tools,
Right.
they can be manipulated to support false conclusions if they're not grounded in physical reality.
All right.
He had this analogy of a glass of water.
Okay.
Saying a glass is half full is mathematically the same as saying it's half empty, right?
Yep.
But the meaning changes depending on your perspective.
I see what you're saying.
Yeah.
Just because something can be expressed mathematically doesn't mean it's actually true in the real world. It's like that saying, figures don't lie, but liars figure.
Exactly. That's a great way to put it.
Yeah.
So Dingle, he believed that something similar might be happening with relativity. The math might be beautiful,
Yeah.
but it could be overshadowing a lack of real solid evidence.
So like being so impressed by this beautifully crafted house that you don't even notice it's built on a shaky foundation.
Exactly, yeah.
That's a great analogy. So were there other scientists who shared this kind of skepticism?
Oh, yeah. The audio clip mentions several others,
Oh, okay.
like Charles Lane Poor.
Okay.
He was a respected astronomer.
Right.
And he pointed out that Relativity kind of clashes with our common sense understanding of the universe.
Yeah, I can see that.
The idea of time being relative or objects shrinking as they move faster,
Yeah.
it just doesn't really jive with our everyday experience.
Yeah, it definitely takes some mental gymnastics to wrap your head around those concepts, for sure.
For sure, it does.
So yeah, for some scientists, relativity just seemed too, I don't know, too far out there,
Right.
too divorced from reality. What about Louis Essen,
Yes.
the atomic clock guy? Didn't his criticism seem a little more technical?
Yeah, his issue was more about the foundation of the theory. He argued that relativity wasn't actually a true physical theory,
Okay.
but more like a collection of assumptions and, mathematical tricks.
Right.
He felt it lacked a solid grounding in real observations and experimentation.
So kind of like, again, that beautiful building on a shaky foundation. Might look great, but is it
Right.
actually stable?
Exactly, exactly. And then you have these heavy hitters like Rutherford,
Yeah.
the father of nuclear physics, calling it nonsense.
Wow.
Now, the clip doesn't get into his detailed reasoning,
Okay.
but it's clear that even some of the giants of physics weren't entirely convinced.
It really makes you think what we consider scientific truth. It's not just about some brilliant mind having a eureka moment.
No, not at all.
So this whole idea of evidence being suppressed, that's a bit disturbing, don't you think? It suggests that the process isn't always as open and transparent as we'd like. Is there more about that in the audio clip?
Yeah, the clip focuses a lot on the Michelson-Morley experiment and how the scientific community responded.
Right.
It was designed to detect the Earth's movement,
Right.
but it failed.
Right, which was a huge problem.
Exactly, because it challenged the idea of a moving Earth, a core principle of the whole Copernican model.
Exactly. So the audio clip is suggesting that instead of seriously considering that possibility that the Earth might be stationary,
Right.
scientists kind of scrambled to come up with explanations that would just keep the existing paradigm intact.
Yeah, they really did.
Like that whole Lorentz Fitzgerald contraction theory,
Right.
where they suggested that the experiment's measuring arm was actually shrinking as it moved through the ether.
Yeah, it did seem like they were kind of bending over backwards to make the data fit their preconceived notions.
I know, right?
And then, according to the clip, Einstein comes along with his theory of relativity,
Right.
which basically removes the ether altogether.
So instead of explaining the Michelson-Morley results, they just got rid of a key part of the whole experiment. It's
Right.
like they swept the whole problem under the rug instead of actually dealing with it.
Right. That's what the audio clip is arguing, that both the contraction theory and relativity were ways of just avoiding those uncomfortable implications of the Michelson-Morley experiment.
Wow. So they were more focused on protecting the accepted narrative
It seems that way.
than on actually following the evidence wherever it may lead. That's pretty unsettling.
It is a bit concerning. The clip goes on to say that these theories, especially relativity, have become so ingrained
Right.
that any evidence that challenges them is just, ignored or dismissed.
So that explains why all those scientists we were just talking about,
Yeah.
like Dingle, Poor, Essen, even Rutherford,
Right.
they've all had such a hard time getting their criticisms heard.
Exactly. Yeah. The source paints this picture of a scientific establishment that's really resistant to anything that might challenge its dominant narrative.
Wow. It makes you wonder if there are other, potentially groundbreaking scientific discoveries out there that are just being overlooked
Right.
or suppressed because they don't fit with this accepted worldview. This whole conversation has been a real eye-opener. I never realized that the world of science could be so, I don't know, complex and nuanced.
Yeah, it really is. It's important to remember that science is an ongoing process of discovery and debate.
Yeah.
Theories are always being challenged and refined as new evidence comes up.
Right. And sometimes those challenges come from unexpected places, like scientists who were once strong supporters of the very theories they later come to question.
Absolutely. It really highlights the importance of keeping an open mind and
Yeah.
being willing to question even the most established ideas.
This deep dive has given me a lot to think about. I'm curious to hear what other insights this audio clip has in store for us.
Let's do it. I can't wait.
Okay, so we've got these scientists, some really heavy hitters, questioning Einstein and relativity. But what were their, specific criticisms? What didn't they like about relativity?
Well, one common thread seems to be that it just didn't really fit with our, everyday experience of the world.
Right.
Charles Lane Poor, the astronomer we talked about it, he talked about how it clashed with common sense.
Yeah.
Think about it, like time being relative and things getting shorter. the faster they move.
Yeah.
It's not exactly intuitive, is it?
No, definitely takes some mental gymnastics to wrap your head around that.
It does, for sure.
So, for some scientists, relativity just seemed, I don't know, a little too out there, too divorced from reality.
Right. Yeah.
What about Louis Essen,
Yeah.
the atomic clock guy? His criticisms seemed like more technical, right?
Yeah, his issue was more about the foundation of the theory.
Okay.
He was arguing that relativity wasn't a true physical theory.
Right.
It was more like a bunch of assumptions and, clever mathematical tricks.
Right.
So he felt like it lacked, that strong basis in real-world observations.
So it's like, again, it's that beautiful building, but built on a shaky foundation.
Exactly.
Right. Looks impressive, but is it actually stable?
Exactly. And then, of course, you have, the heavyweights like Rutherford calling it nonsense.
Right.
Now, the audio clip doesn't go into his detailed reasoning,
Okay.
but it's clear that even, some of these giants of physics, they had their doubts.
It really makes you wonder about what we even consider scientific truth, you know?
I know, right.
It's not just about, like, one brilliant mind having this aha moment.
Right. Definitely not.
There's a lot more to it, isn't there?
Yeah. Science is an ongoing process.
Yeah.
A real back and forth of ideas, evidence.
Right.
Sometimes it's messy. Sometimes it's, contentious. But that's how we actually get closer to the truth.
I like that. So this whole idea of evidence being suppressed, that's a bit disturbing, isn't it?
Yeah, it is a bit.
It suggests that the process might not be as, open and transparent as we'd like to think.
Right.
Was there more about that in the audio clip?
Yeah, it definitely focused a lot on that whole Michelson-Morley experiment and how the scientific community reacted to these unexpected results.
Okay.
The experiment was designed to detect the Earth's movement.
Right.
But it failed.
Right. And that was a problem.
It was.
Because, like a stationary Earth, it would have turned their whole understanding upside down.
Totally.
So is the clip arguing that instead of considering that, like, possibility that the Earth might be stationary, scientists kind of scrambled? Like, they came up with explanations to just preserve their existing worldview?
Yeah, that's exactly what it's saying.
Like the whole shrinking arm theory?
Yeah.
It seemed like they were really trying to make the data fit their preconceived ideas.
Yeah, it does seem that way.
And then Einstein comes along with relativity.
Right.
Which, instead of addressing those Michelson-Morley results, they kind of just remove the need for an ether at all.
Right, they basically sidestepped the whole issue instead of resolving it.
Wow. So they were more concerned with protecting the accepted narrative
It seems that way, yeah.
than actually following the evidence, wherever it might lead. That's unsettling.
It is. It is a bit concerning. The clip goes on to say that those theories, especially relativity, have become like so ingrained
Yeah.
that any evidence that challenges them is just met with, resistance.
So that brings us back to, like, Dingle and Poor, Essen, Rutherford,
Yeah.
like, their ideas being marginalized or dismissed.
Exactly. Yeah, the source is painting this picture of, a scientific establishment that can be resistant to challenges to the prevailing view.
Right.
And it makes you wonder what other groundbreaking ideas are out there just waiting to be discovered if we were only open to them,
I know. This has been a really mind-expanding deep dive.
It has.
We covered so much, from ether to Einstein, from, seemingly contradictory experiments to those claims of suppressed evidence.
Yeah, it's been quite a journey.
It has.
And while we've explored, a lot of complex ideas, I think there's a simple takeaway.
What's that?
Keep asking questions.
Yeah.
Don't be afraid to, challenge that status quo, to dig a little deeper, to consider those different perspectives.
Because even when it comes to something as, fundamental as the nature of the universe, there's always more to learn. There's always more to explore. Who knows? Maybe you'll be the one to uncover the next big breakthrough.
I hope so.
But until then, keep those minds open and stay curious.